Hello, 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 everyone, and happy Wednesday. Welcome to the LocalStack Community Meetup for May. So excited to have y'all here with us today. You could be anywhere in the world, but you are here spending your time with us, and for that, I am grateful. For anyone new, I am Kaya Imani from the DevRel team here at LocalStack. We do these meetups to bring folks together that are building in the cloud, serverless, DevOps, platform engineering, and all that fun stuff, just to create a space where we can learn and share real world experiences. Quick housekeeping before we get started. This session is being streamed live on YouTube and is going to be recorded. So if you have to hop off early and rewatch later, we've got you covered. Also, feel free to drop questions in the chat at any time during the presentation. We'll make sure to save time at the end to go through them. And if you haven't joined already, definitely come hang out with us in the LocalStack community Slack. That's honestly where a lot of the best conversations happen after the meetup. So definitely meet us there. Today, our session is especially exciting because we've got some new faces on the meetup, and hopefully ones you'll be seeing a lot more moving forward. Joining us today is going to be Shelton Graves, who is a senior technical product manager, and Christian Payeres, who is a full stack engineer, both here at LocalStack. Welcome, Shelton and Christian.
I'm excited to be here. My first one. So hello, everyone. I'm Shelton Graves, as Kai mentioned, Senior Technical Product Manager at LocalStack. I've been in the cloud native space for over a decade. Worked everything from cloud native infrastructure, Kubernetes, serverless, developer tooling. So nice to be with you all today. Looking forward to it.
Thanks for the introduction, Shelton. Christian, why don't you introduce yourselves to the world?
Yeah, sure. Thank you. I'm Christian Payares. I've been a full stack developer for over a decade as well. And lately I've been focusing more on serverless and infrastructure as code, and now working on App Inspector. And I will be happy to answer any of your questions in the chat, and happy to let you guys start.
Yes. All right. So before I let you guys take it away, just going to introduce our topic a little bit. We're talking about observability, folks. Every cloud developer has felt a pain point around observability at some point in their career. So App Inspector is a new product or a new feature that we recently launched. And yes, Shelton and Christian, you guys take it away and tell us a little bit more about App Inspector.
Absolutely. So we'll go ahead and get started. So topic of our presentation is no more black boxes. And as we get into it, we'll demystify what's behind the black box with App Inspector and LocalStack. So let's say you build an order service and you trigger an order, right? The payment fires, the shipping fires, the notification fires, but then something silently fails. So where do you start in the process of debugging what things went wrong? So in a traditional request and response system, as you know, when a failure goes wrong, you have a single uncallable traceable stack that you can go and find where the issue went wrong. But here in event-driven architectures, there's services that fan out on services calling other services, services hitting things simultaneously. Each may produce its own downstream events. So it makes that really difficult because there's no single thread to follow. Instead, you're having to open up multiple different log groups on separate tabs. You're trying to correlate timestamps of when things happened, and trying to piece together really what the chain and order of events to kind of look between the needle in the haystack of where something went wrong. So instead, you push to AWS. Then let's say you push it to either a personal account that you have for testing, or let's say you have a shared stage environment within your team, somewhere where you can really emulate what the behavior of the application is going to eventually run once you have it in production. But that comes with a cost, right? If you deploy it, it's going to take 2 to 10 minutes per every iteration. Every test run incurs a AWS charge. Shared staging creates contention when you have multiple engineers on the team, because you're all kind of fighting for that resource and have to kind of plan accordingly of, hey, I'm going to be in stage, I'm deploying this change. Can someone be out of it? And the bugs sometimes are intermittent. Depending on the timing or the event order, you may find yourself triggering dozens of workflows just to reproduce the same error. So we refer to this, AWS is often a black box because the data exchange between the two services or multiple services is unknown. You have some things such as silent failures where, let's say a Lambda times out mid-execution, and then there's no useful error log. So you don't really know exactly what went wrong. Or let's say, since a lot of these services are serverless, the cold start problem. So if you're familiar with the cold start problem of a services, there's a slight delay. So the cold start delays one consumer, and now you have things going through the chain a little bit delayed, which caused an error for downstream services. Or let's say that there's the dead letter queue, message ends in the dead letter queue, but now the payload's gone. You know something failed, but you don't know why and what happened. So these are all common problems with event-driven debugging and event-driven applications. AWS does have observability tools, but they do require setup and interaction to actually observe the services that you're procuring through those tools. And then also, they still cost money to run. Again, we touched on this earlier. Every 2 to 10 minutes, every deploy cycle, every kind of debug, every iteration, and you have to kind of wait through that period. And every test comes with a cost. I mentioned the observability cost, but actually the actually compute and infra to run and spin up your application during testing also adds up as well. So here comes an app inspector. So with LocalStack, you can emulate AWS services on your laptop. So that deploy cycle, you don't have to wait those 2 to 10 minutes that we mentioned. There's no provisioning time. There's no AWS bill for every test run. That feedback loop is essentially sped up. And then also, you're not having to incur those costs. But running locally doesn't mean that you can't see what's happening. You've just moved the black box from the cloud onto your laptop. But that's where App Inspector comes in. So it's not a separate tool that you install. It's not a sidecar. It's not an extension. It is natively built into LocalStack. So the moment those services are running locally, App Inspector is actually seeing every trace of every event, every invocation, every payload between your services. That's visualized in real time, which we'll get to in the demo shortly, right in front of you. So you can actually trace what triggered what. You can drill into the payload. You can see what caused the failure, and you can see the actual order of the events and how they were processed. All for free or part of LocalStack with no waiting and no additional costs, no AWS bill. So what does this actually mean in practice? So you no longer have to sift through logs of various different services to kind of guess where things are and parse through various different services and in views. You get a single view of everything that happened in your application, what order it happened, which service called another service with the full payload. And because it's native to LocalStack, there's no setup tax. You don't have to configure anything else. It's actually just built into native. So the result is that we've seen developers cut their debugging time up to 70%. And it's not because they're doing things more efficiently. It's that they stop spending time searching through for the bugs and having those rise right in front of them, and they're able to get the visibility that they need in order to fix the problem and debug and cut the process of looping the software. So we have a demo for you today. So we have a small inventory management app, a quick walkthrough. So let's say you have a CSV of some inventory data, and that CSV is uploaded to S3. We have a Lambda that will read the whole CSV file from S3, and it will loop through every row. As every row goes through and gets processed, it will convert that into a JSON string, and then it'll be added to a batch. So every 10 rows, it flushes the batch, and then it creates 3 SQS API calls. And then for there, SQS holds these messages until a worker is ready to pick them up, which is the Lambda you see on the right there. That Lambda will pull the queue, and it will grab up to 10 messages at a time. And for each one, it will write those into Dynamo. So it's a fairly simple inventory management application. So we'll go ahead and enable App Inspector. So we have App Inspector enabled. What I'll go ahead and do is deploy our application that we just saw. So I will deploy it here. And upon deploying the application, I will start to we see the CloudFormation going. It's deploying the application. We can see all the events of deploying this application in real time. It's creating the S3 bucket. And as it's continued to process, it's almost done with every service. And now it's complete. So I can peek in here, and let's just taking a peek at the deployed services. And if I zoom out here, we can see all the events that it took to deploy this application. But this is just the deploying phase. So nothing super exciting here, no triggering of events, just kind of deploy going through the CloudFormation. So what I'll do is I'll just clear the operations to have kind of a fresh, clean slate of events. And what I'll do is I'll upload a CSV. So upload a CSV, and now we can see actually that workflow that I showed previously. So we can see that CSV, scroll back to the top. We can see that CSV upload to S3. We can see the Lambda processing all the rows. We can see those JSON files uploaded to the SQS queue. And then we can see that Lambda and then processing all the insertions all into DynamoDB. I click the view graph. Actually, I can actually see, I can drill to every request and response. So if I zoom in here, if there's any particular part of this chain of events, I can drill into. So I can see the payload, I can see the request, I can see the response. If I need to pull the trace ID or span ID, I can pull those here. But I can drill into every interaction, and you can see this nice, beautiful flow chart where I can follow the events, and you can see as a byproduct, these are all the insertions into DynamoDB. And the thing is, I didn't have to set this up. You guys watched it real time. I didn't have to instrument any code or go to any of the side service to kind of make the connection. I just ran the application in LocalStack, and I was able to see everything that was deployed in every interaction between each service. So I'm going to go back, and I'm going to clear the operations, and I'm going to drop another CSV. So let me upload another CSV into the application. I'll let that run. And now we see some errors. We see some errors that we can do. Now we can see there's 2 errors. And now if I view the graph, actually am brought directly to where the problem went wrong. So in this case, the SQS to DynamoDB Lambda is failing because one of the CSV records has bad data. So as we go through and inspect, we actually can see the value can't be converted to a number. So the CSV has a row where the quantity field has a NA, it expects a numeric value. It caught that, and it gave us an error. So actually can go through and, in this case, make change to the CSV. But if there's a particular service in the chain of events, you're actually to be able to point out exactly where the problem happened. And then you'll be able to go ahead and diagnose exactly where the error occurred, and then go back, redeploy, and then see if that remediated the issue. So we were able to inspect this application within seconds with viewing where the actual problem is. We find out where it is, we go fix the code, and we go back, retest, reply. So we've significantly cut down the time it takes to actually debug this application and get it working. So we will pop back here in a second. Let me pull up the presentation again. Yeah, full screen. Okay, cool. So everything I showed you, the event trace, the payload, the exact sequence of events, you had to look at manually. We were the ones interpreting it, but we're in 2026. AI coding agents are writing code, they're deploying changes, we're running autonomously, running tests. So the next question is, well, what if an agent could query App Inspector directly? What if instead of you reading the trace on a GUI interface, the agent reads it, it diagnoses the failure, it fixes the code all in a local sandbox before it touches anything on AWS. So that's exactly where we're headed. Today, you do it. Tomorrow, coming soon, an agent can query App Inspector, diagnose the problem, and retest locally. So let me go through what this looks like in practice. So an agent wants to test a code change. It will deploy that to LocalStack. Again, the advantage is there. There's no AWS account. There's no provisioning, no cost associated. The application would run inside the AWS emulator. And then from there, instead of the agent having to guess of what happened, actually can query App Inspector directly. So again, see all the events fired, the payloads, what succeeded, what failed. From there, since it actually can see and read, it can diagnose. So this is where this sandbox becomes a full agentic loop, where we're closing the loop with the agent being a part of this loop. So now the agent doesn't just necessarily write the code to build the application in the first place. It actually can observe the runtime of behavior of the code as if it was a real AWS environment before we're actually getting to deploy that. So let me show you what this looks like in practice. So we'll pop back out to our Visual Studio Code instance. We'll clear that. And then we'll open up our Claude. And for this instance, I'll just ask Claude, can you inspect the deployed application on LocalStack? And what Claude will do is Claude will call the LocalStack MCP. When I give it permission to do that, it will call the LocalStack MCP tool for App Inspector, and we'll go through all the traces that we saw, and it will start to inspect the application and then understand what went wrong, where the errors went wrong, and then it will give us a full readout of everything that's in the application, what things went wrong, what interactions. And then from there, we can actually work with Claude to actually mitigate and fix and debug and redeploy. So we can see it gives kind of a readout. There's likely a test error. You can see, and then it's like asking, do we want me to dig into the in-flight messages or Lambda logs while it's processing? And then we just say yes. And now we have this full agentic loop where App Inspector, LocalStack, and the agent are working together to debug an application. So we have that full loop here. So that's where we're going with App Inspector, as not only as developers, we can deploy and make it easier to debug applications. An agent now can also help us and can find the bugs and then help us remediate the bugs as well. So I'll pop back in our presentation. All right, so that concludes our presentation today. Hopefully you found this helpful and informative. I have my contact information there. Happy to reach out. Please reach out if you want to learn more, have a conversation about App Inspector, with a demo for your team. We'd love to hear from you all. So both my email and my calendar, feel free to set up time to talk. We'd love to talk about App Inspector a little bit more.
Yeah, you're muted.
My bad. Thank you all for that presentation. I thought it was so cool that App Inspector, or when you use App Inspector with the Claude code agent, I mean, I didn't even know it could do that, so I'm pretty happy to know that it can. Awesome. So let's get into some questions. The first one: what is or was the biggest pain point or workflow frustration that originally inspired App Inspector? Either one of you can respond to this one.
Well, I can personally say that anytime I develop an application, I feel I'm blind. Anytime I try to debug something, it's really hard to find. And the demo that Shelton prepared, in reality, is a very simple process. In a real application, you will have like dozens of lambdas, maybe many buckets, many different resources, and it's really hard to debug what's wrong. With App Inspector now, it's just very simple and plain, and especially when we prepare App Inspector for agentic development, I guess there would be very little for you to do. The agent will do almost everything for you. So
yeah,
I guess that's it.
Very awesome. Yeah, that makes sense. Like, Shelton, do you have anything else to add, or like blind debugging? I mean, I think that's like a good general consensus that we all got. You know?
Yeah, no, absolutely. Like blind debugging, and I think the deployment process can't iterate that enough of deploying like that retest, redeploying to AWS. Obviously, just eats into your day, and you have to kind of keep doing it, and then watch it fail, retest. Just gets really monotonous of waiting on resources to deploy to AWS to kind of see did it work, did it not. So I think that part is the biggest I guess advantage that I saw with using App Inspector.
Yeah, for sure. I don't know about you, but after like 2 or 3 retries, I gotta take a break. I'm not, you know what I mean? It's like, I've got to take a break. I gotta go take a walk or something. So yeah, I definitely see how this could like speed up developer productivity. And it restores some developer confidence in what's going on. So for sure. Okay, next question. And this is the question everybody wants to know. Which LocalStack plans have App Inspector?
So App Inspector is included in all plans. So if you are on our hobby plan, which is our free plan, you will be able to see up to like 10 events. So the event list that we showed earlier, you'll be able to see up to 10 events. And then if you move over to one of our paid plans, you actually can see up to 1,000 events there.
Oh, wow.
So every plan is available. So today, if you go sign up for a hobby account today, go try out App Inspector today. You'll be able to test it and work with App Inspector.
Oh, that's awesome. So you heard it here, folks. You can use it for free and test it out. That's really good. Okay. So I've got another one. For teams relying on CloudWatch and distributed tracing, how should they think of App Inspector in their local workflow? Would it be like a replacement, or would it be like something that would stand beside their current flow, or what do you think?
I guess for me, I would just entirely replace it right now. For the stuff I'm working on, basically with App Inspector, I can have anything I need and find what's wrong and try and do the development cycles one on one. So to me, just I replace it.
Okay, so you guys could totally not use CloudWatch and rely on App Inspector, which is probably a good thing. I mean, I think App Inspector is a better UI personally. So, all right, final question. How do you see observability evolving for local first cloud development over the next few years?
Yeah. I mean, I think one part, obviously touching on the AI, I mean, I'd be remiss not to think in the next few years that AI will not be involved in the observability conversation, right? And I think it's what I demoed is, I think, the kind of journey, right, of like agents probably being even more autonomous in the workflow regarding observability, giving slowly as things progress. Right now, obviously, I could have ran it on dangerously skip permissions. I did not. So you all saw the prompts for me to approve what Claude was asking me to inspect, and then also the remediations. But I think as we move forward and in our trust in the guardrails of AI become better of how we can steer AI into our desired results, but in a way that is safe for enterprises and for companies to use. I look at, from observability perspective of having more guardrails of AI being able to run autonomously, fix things without kind of any human interaction, where we kind of define some guardrails of where that's safe and where that's not. So I definitely think that's in the cards for the future as, more enterprises, we get deeper into the adoption of AI and like figure out ways of how we can put guardrails where it can fix things, without kind of our need that's actually more in production environments or staging environments, so environments closer to the real thing versus, so I think local first is like kind of what you're seeing here, but I think that story is going to evolve as we kind of get into more production and staging cases.
Very good. Very good. Can you all hear me well? I just had some technical difficulties happen. Okay, cool. Very awesome. That is it for our questions. I guess we could go ahead and wrap it up here. Thank you both for the demo, and thank you to everyone who has joined us today. One more plug. Well, two more plugs, actually. So we've got App Inspector blog posts. If you prefer to read blog posts and kind of follow along as you read, instead of watching along, you can also like have it as a companion. You could do both. Check that blog post out. Scan that QR code and it'll take you to our App Inspector blog post. And if you haven't already, definitely join the LocalStack community Slack. Again, that is the best place to continue the conversation and ask follow-up questions and share what you're building and stay up to date on future meetups and releases. We've got more sessions coming soon, so keep an eye out on our socials and our meetup page. And with that, have a great rest of your day, and we'll see you next month. Bye.
Thank you. Bye-bye.